Okay, so Pythagorean theorem is when we have right triangles. So if I have a right triangle and I know two sides, so if I know this is A, B, and C, if I know two of those three sides, I can find the third using the Pythagorean theorem. Does anyone remember what the Pythagorean theorem says? Yep, A squared plus B squared equals C squared. We talked about this briefly at the start of the year. You guys did some Pythagorean theorem when you were finding distance. C here must be the hypotenuse. That's the only requirement, is that C is the hypotenuse. The order of the legs doesn't matter, so it doesn't matter which one you put first in the equation, but the hypotenuse has to be C. It's got to be opposite of that 90 degrees. Okay? So, that's our Pythagorean theorem. So if we have a right triangle, A squared plus B squared will equal C squared. This converse just means we're going the reverse order. So the converse is just telling us that if we have the sum, so if we know this is true, so if I give you three numbers and we plug it into the Pythagorean theorem and it works, then we have a right triangle. Okay? So they're really saying the same thing. And then there's one other word. You should know Pythagorean theorem already, but there is something called a Pythagorean triple. Pythagorean triple are whole numbers that satisfy our equation. For example, 3, 4, and 5 are a Pythagorean triple because when we put this into the Pythagorean theorem, it works, and they're whole numbers. So when I try doing 3 squared plus 4 squared, and if I see if this equals 5 squared, it works out for us. So what's 3 squared? 9. 4 squared? 16. And 5 squared? 25. Is 9 plus 16 25? Yep. So 3, 4, 5 is a Pythagorean triple because it works in our Pythagorean theorem, and the three numbers are whole numbers. They're integers. Okay. If we put decimals in here, it's not going to work. If we put fractions in here, it's not a triple anymore. They have to be whole numbers. All right, so this is what we're going to be doing. We're going to be using the Pythagorean theorem to find missing sides, and then I'll also give you three sides, and you'll have to tell me whether or not it forms a right triangle. So, example 1. Let's see, x, y. Ooh, I labeled that in the wrong order. So there's the triangle XYZ. We are told that XY is 7, XZ is 14. We want to find YZ. So we'll label. So XY is 7 and XZ is 14. I didn't hear what you said. So we want to find YZ. So the only way to find YZ is to use our Pythagorean theorem. So Pythagorean theorem is A squared plus B squared equals C squared. So C squared, C represents the hypotenuse. So which of these values is the hypotenuse? 14. The 14. So we know that this should equal 14 squared. And then we can just say, well, A squared plus 7 squared. And we're going to try to find our A, our other leg. We don't know that. We need to find it. So what's 7 squared? 49. What's 14 squared? 196. How do we get the A squared alone? Subtract the 49. So A squared is equal to 147. And then how do we get A? Take the square root.
Is that like what the whole assignment is pretty much?
Well, it's part of it, yeah. So the square root of 147 we should simplify down. So here's our perfect squares. Is any of our perfect squares factors of 147? 49 is, yeah. 49 times what? We did simplify this one down yesterday. 49 times 3. So what's the square root of 49? 7. And then we just leave the square root of 3. So that's our YZ. In a minute.
That was confusing.
What part?
Every part.
Every part? Well, let's do another one. Let's try again. Try the next one. So next one. Let's see. This is triangle PRQ. I'm going to label it as PRQ. So here we know PR is 6. PQ is 3. We want to find the missing side, the QR there. So how am I going to set this up in the Pythagorean theorem? Okay, well, let's see. Which side's the hypotenuse here? Look at your triangle. The one that has nothing on it's your hypotenuse, because that's opposite of the 90. So we are going to solve for c squared, so equals c squared. So the other two legs are 3 and 6. So we'll say 3 squared plus 6 squared. So what's 3 squared? 9. What's 6 squared? 36. Okay, so it's 9 and 36. 45 is c squared. So if we take this square root, any perfect squares fit into 45? 5's not on our list of perfect squares. 9 does, though. 9 times what? 9 times 5?
3.
Yeah, 3 square root of 5. Is that one okay?
If they don't have a perfect square, you just square root it.
Yeah, if they don't have a perfect square, then you just leave it.
So, like 14, like when you do 28 squared plus 20 squared, it's 1184.
There's a perfect square in there. You're just going to have to find it. Okay? So are these two okay?
Yeah.
All right, so let's look at this. So now we want to decide whether or not they form a right triangle, the 3 sides that are given, and then whether or not it's a Pythagorean triple. Okay? So to decide whether or not it forms a right triangle, we put it into the Pythagorean theorem. And then it's a Pythagorean triple if they're all whole numbers. So when we're putting this into the Pythagorean theorem, the only thing we need to really be concerned with is that our largest side is the hypotenuse. So the longest side that's listed, we have as our C. Okay, that's the only thing we need to be concerned with. So here the 3 sides are 9, 12, and 15. So how will we set this up? Okay, so 9 squared plus 12 squared is equal to 15 squared. Now we have to see if this is true or not. So what's 9 squared? 81. 12 squared? 144. When we add those two together, what do we end up getting? What? I just didn't hear you. 225, okay. And then what's 15 squared? 225. So are those equal to each other? Yep. So yes, this is a right triangle. Okay. And is it a triple? So are the 3 numbers whole numbers?
Yeah.
Yep. So yes, it is a triple. Is that one okay? All right, let's try the next one. The 3 numbers are 21, 42, and 54.
21 squared, 42 squared.
Okay, so 21 squared plus 42 squared, does this equal 54 squared? Okay, so 21 squared, 441 plus, what's 42 squared?
1,764.
Okay, when we add those two values together, what do we end up getting?
2,100 some number.
They're not equal.
What?
1,805. 1,000?
No, 2,205.
Yeah,
That's
I'm
better.
saying, I know 1,000. They're going to go up there.
Okay, equals, well, it's 54 squared.
2,916.
So are these two equal to each other? No, so this is not a right triangle. Does that make sense? Okay, last one. 4 square root of 3, 4, and 8. Which one do you think is the longest side here? 8 probably is. Okay. So here, when we set this up, we have to do 4 square root of 3 squared, and that's the way how you'll have to put it in your calculator to make sure you square the whole thing. Okay. Plus 4 squared, does this equal 8 squared? So when you put in your calculator 4 square root of 3, all of that in parentheses, and then you square it, what do you end up getting there?
Some ridiculous number.
Is it 8?
No.
So then, I don't know who was up there.
Oh, 12, I lied.
No.
4 square roots of 3 squared.
Yeah, you didn't put this all in parentheses, though. Whole thing needs to be in parentheses.
So it's all square, right? Basically?
So the whole thing is squared, right?
144.
So it'd be
12.
parentheses.
Nope, you don't have the whole thing in parentheses. Nope. When you put your parentheses on, 4 square root of 3, and then your 3 here opened up a new parentheses.
48.
So you have to close it, and then square.
So 48.
48, yep. Plus, what's 4 squared? 16, all right, 48 and 16.
64.
It's not 64, it's a lie.
64.
Oh,
What is 8 squared?
64.
64. So are these equal?
Huh?
So yes, this is a right triangle.
I'm always right. What? Yes.
Is this a triple?
Yeah.
Yes.
No.
Are these all whole numbers? Is the square root of 3, is that a whole number?
It's right there.
No, that's a decimal, so this is not a triple. So is that one okay?
No. It's not a triple.
All right. So now we are going to give you 3 points, and we want to verify that we have a right triangle. Okay, so to verify that we have a right triangle, we need the distance of the 3 sides. The graph paper is only here if you are someone who's very visual, who needs to put the points down to see what the 3 sides are. But otherwise, we just need to go through and find the distance. So what's your distance formula?
D equals x1 minus x2.
Yep, x2 minus x1 squared plus y2 minus y1 squared, or change of x squared plus change of y squared. Okay, so we need to find the 3 sides of the triangle and then put it into the Pythagorean theorem. So one of the sides will be p to q. Another side will be q to r. And the final side will be p to r. Yep, we have to do it 3 times. So change of x. So from p to q, we go from 3 to negative 3. So how much does that change?
Come on, 3.
From positive 3 to negative 3, it changes 6. So 6 squared plus your y's go from 2 to 6.
4.
So 4 squared. So what's 6 squared? 36. And 4 squared? 16. All right, 36 plus 16.
48.
52.
Oh.
We can just leave it as that. We don't need to simplify it down. Just leave it as a square root of 52. Okay, q to r, we're going to do the same thing, distance formula. So how much do your x's changed from q to r? From negative 3 to positive 5? 8. So 8 squared plus, how much do your y's change from 6 to 5? 1, so 1 squared. So what's 8 squared? 64 and 1 squared. So when we add these two together, what do we get? Yep. Okay, now P to R. So from P to R, so we're going 3 to 5. How much does that change? 2.
3.
And then 2 to 5 is 3, yep. So 2 squared? 4. 3 squared? So 4 and 9 gives you, okay, which of those is the longest? 65. So that means we're going to take the square root of 13, square it, plus the square root of 52, square it. Does that equal the square root of 65 squared? What happens when you square a square root? Yeah, it gets rid of it. So this is really just saying, does 13 plus 52 equal 65? That's why we don't have to worry about simplifying them down, because we're going to square them at the end. So does 13 plus 52, does that equal 65? Yep.
So why put all that square junk on there?
Then what's up with the graph?
The graph is for those of you who need to see that visual. So like you need to see that this is P, this is R, or Q, sorry, and then this is R. So for those of you who need to draw it out to see what the three sides are, you don't need to use the graph, but if you want to, you certainly can.